Okay, we have a force being applied on an object on the ceiling at 20 degrees to the right. And we are figuring out what is the coefficient of static friction and how much force is static friction is applying to this direction, the x direction. So to calculate first, we have to check if it is actually in static friction. So what you do is you have static friction equals mu times normal force. Normal force is equivalent to cosine of 20, which is the upwards direction of this component of the force applied, minus the y component downwards of Fg. And that total force is 91.95 newtons. You times that by the coefficient of static mu, which was given in the problem, and you get 59.77 newtons is the max force static friction can hold. Well, the static friction acts in this direction, so the counteracting force is sine 20 times 150 newtons. And sine 20 times 150 newtons is 51.30 newtons. So then, since it does not exceed the static friction, that means static friction is equal to the component of the x direction, which is because the net force, since it's stationary, is 0. So then static friction must equal 51.30 newtons to the left. Now to move on to the second part of this equation, we have a change in the constants of, now we have mu static is 0.45 instead of 0.65. So then we do the same process as before, as we check for the static friction, which is mu static times the coefficient of forces in the y directions, which is the normal force. And that gets us 41.37, which in the previous part, sine of 20 times 150 newtons is 51.30 newtons. So by that case, this is not in static friction. And after checking that, now we need to move to kinetic friction and see how much it is accelerating to the left, or what direction it is accelerating it. So force of kinetic is equal to 0.35 times the normal force, which is going to get us 32.18 newtons. And then to calculate the forces in the x direction, we're going to have the force in our situation in the positive x direction, and we're minus the forces counteracting them in the negative x direction, which this is in the positive x direction minus the negative x direction, which gets us 19.12 newtons is the sum of our forces. By the sum of our forces is equal to mass times acceleration, so acceleration is equal to the sum of our forces divided by mass, which is 19.12 newtons divided by 5 kilograms, which will get us acceleration of 3.82 meters per second squared to the right.